Factoring easy trinomials. Let's start this video a little bit with some review of some stuff that you should already know, that being how do we multiply a couple of binomials. Let's look at, if I ask you to expand x minus 3 times x plus 6. Yes, you probably at this point are going, hey, that's FOIL. FOIL is something we use to help us remember and keep track as we multiply the terms together between two binomials. If I multiply the first two things here, an x times an x, I get an x squared. The outside two things, which is x times plus 6, I'm going to get plus 6x. The inside, negative 3 times x, is negative 3x. And the last two pieces, the last two terms, negative 3 times positive 6, gives me negative 18. This polynomial is exactly equal in value to this top one. It's not as pretty as it could be. Make sure you collect like terms. Positive 6x and a negative 3x together leave positive 3x minus 18. There is what happens when you expand. Now let's look at something that happened as we FOILed that out. I'm going to make some of this go away and take this middle row out so I can draw some arrows. Where did, for instance, the negative 3 or this positive 3 come from? If I take negative 3 and positive 6 and I find their sum, in other words, I add the two together, I get that 3. Where's the negative 18 come from? If I take those same two numbers and I find their product, I get negative 18. Seeing that pattern is going to help us when we turn around instead and go back to what we were doing in the last video, and that's do some factoring. What if I ask you to factor x squared plus 3x minus 18? Remember what factoring means. I want to rewrite this as a product, meaning some things being multiplied together. What sort of things? Prime factors. Factors we can't break down anymore. I want to write this as something times something. In the last video we were talking about greatest common factors. Always look for that first. This has three terms, x squared, 3x, and negative 18. Is there anything they have in common? No. There is no common factor in this question. We need another way to factor, and this is what this video is on, and factoring something called an easy trinomial. How do I know that this is what's called an easy trinomial? Easy because there's no number here. The number in front of the x squared term is just a 1. Trinomial, remember polynomial meant many terms. Trinomial means 3 terms. I see in this question 1 term, 2 terms, and 3 terms. So it's an easy trinomial. When you see an easy trinomial, you can go ahead and draw your brackets. Now all we need to do is fill them in. The first thing in each of your binomial terms are going to be the two things that would multiply together to get this x squared. Obviously, the only way to multiply two things and get x squared is to multiply x times x. The rest of your binomials, if you think about what happened up here with FOIL, are going to be two numbers. The two numbers that you use always add up to the middle term and multiply to be the last one. I need two numbers that add to make 3, multiply to make negative 18. Well, we know from our FOIL example what those numbers are. That negative 3 and plus 6. That is the answer if you're asked to factor this easy trinomial. Let's look at a few more. There's all kinds of twists you're going to see as we do this. What if I give you factor m squared plus 15m plus 56? The first thing you have to do, is there a GCF? Well, first off, there's no number in front of the m squared. The only thing that could come out of here would be m's. Are there m's in every term? No. The only number that can come out of here is a 1, and factoring out a 1 doesn't help. So we don't worry about using a 1 as a GCF. So obviously we're not going to use that kind of factoring. There must be something else. In this case, what we're going to do Draw our brackets. Two things that multiply to make m squared, m and an m. Now I need two numbers that add to make positive 15 and that multiply to make positive 56. You may have to play around a little bit to get really good at it. It depends on your adding and your multiplication facts, how strong you are. If you think about two things that multiply to make 56, there aren't a lot of options. From your multiplication tables, 8 and 7 should jump into your head pretty quickly. Do 8 and 7 add to make 15? Yes, they do. Now, factoring is really cool in math. Well, all math is cool, but factoring you can always check. You can always know, did I get the right answer or didn't I get the right answer? How do you check? Think back to what we did on the previous page. This factoring was the reverse of this expanding, of this multiplying. Factoring is breaking something down into a product. If you want to check it, tell me, hey, I'm going to do a check here. Please don't mark this. This is just for me to make sure, and FOIL this out. M times m is m squared. M times 7 is 7m. Inside and last, I collect my like terms, and I make sure that this matches this, and it does. I know I'm right. Now, that said, I know that I'm right. I have a factored answer. It doesn't mean that sometimes there isn't going to be more that we can do, but for now, know that multiplying together is going to be a check that will always work. Let's look at another one. We're going to factor 3x squared minus 33x plus 90. What do we always do first? Don't forget. Is there a greatest common factor? Looking at these, yes, of course there is. 3 can come out of all of those terms. Notice 3 is going in front bracket, just like all the stuff we did in the last section. It will leave x squared minus 11x plus 30. So far, so good. This is right. If I distribute, I get the same thing as the original question. It's not done, however. What's in here is an easy trinomial, and we need to make sure that we don't stop factoring until none of the factors factor. So leave the 3 sit there. Oops, fat pen again. And we're going to draw our brackets, because this is now, what's inside of this bracket is an easy trinomial. Nothing in front of this x squared and 3 terms. So we know what multiplies to make x squared, an x and an x. Now I need two numbers that add up to make negative 11 and that multiply to make 30. I tend to work from the multiplying end of things. What are two numbers that multiply to make 30? Well, I might not see the answer right away, though I'm sure you do. And I might go, well, what about 15 and 2? Those two things multiply to make 30. Can I use 15 and 2 to get negative 11? No, I can't. I could get 17. I could get 13, for instance. I can't. There's no way to play with signs and add those together to get negative 11. There must be another choice. If you work like this, realize that now I can take this 15 and multiply it by something or divide it by something. I'm going to divide it by 3. If I divide this by 3, I'm going to multiply this by 3. And I'm going to get a new pair of numbers that multiply to make 30. I ended up with a 5 and a 6. Can I use those to make an 11? Of course I can. So these are the right numbers. Now here's where your integer skills are going to come in. What signs do I want on them so that when I multiply I get positive 30, when I add I get negative 11? These must both be negatives. There's the answer. Yes, we could go ahead again, multiply it all out and check. Note, if we're going to multiply this out and check, don't forget, this is my check. Multiply the 3 into the first bracket, and then FOIL. Don't put the 3 in everywhere. When we multiply, multiplication doesn't distribute across multiplication. Multiply the first two things, then multiply the whole thing out, and you'll get back to the original question. Let's try this one. AB squared plus 2ab minus 24a. As we did in the first two, we start by looking for a greatest common factor. There is no number that's common to all three terms. However, there is an a in all three that we can pull out as a common factor. That leaves our easy trinomial of b squared plus 2b minus 24. That easy trinomial is going to factor as two binomials, and we need to find two numbers that add up to positive 2 and then multiply to negative 24. We know that b times b is b squared. We know that, or probably you can see that the factors we're going to use, 24 is usually either 6 and 4 or an 8 and a 3. 8 and 3 can't give me 2, but I can with 6 and 4. Now to decide on the signs. Since they have to multiply to be a negative, we know one is positive and one's negative, one way or the other. Since they add to be positive, the bigger thing gets the plus sign. Positive 6 and negative 4 is positive 2. This, if you multiply it all out, again putting the a into the first bracket and then foiling, you'll get back to this question. One more and then we'll look at a rule. X squared minus 10xy plus 21y squared. Look for a greatest common factor. No number in front, so there won't be a number in our GCF. I've got x's and x's, but no x in the last one. I've got y's and y's, but no y in the first one. There is no GCF happening in this question. Is it an easy trinomial? This looks very different than the ones we've been working with, that there's two things squared. Yes, in fact, this is still an easy trinomial. How do you decide? Think about what you've seen so far. Realize there's no number in front of the squared term. This x squared, or the x's go squared, single x, no x. So likely we can factor it as an easy trinomial. There's no guarantee. We'll give it a try. Two things that multiply to be x squared are x and x. Now if you imagine the y's aren't there, we're looking for two things that would multiply to be positive 21 and add to be negative 10. 21 is 7 and 3. To get a positive value, they have to have the same signs. To add to be negative 10, they have to both be negative. Let's think about that again. To multiply to be positive, they have to have the same signs. To add to be negative, these have to both be negative. Now what about the y's? How can I multiply and get 21y squared? If I put a y and a y, I'm going to get the y squared. How do I add to get negative 10xy? Realize if I foiled this right now, outside would be negative 7xy. Inside is negative 3xy. This is going to work. Play with that one a little bit if you're not sure. And if you have questions, be sure to get a hold of me. Okay, now a quick rule. When we talk about easy trinomials, or trinomials at all for that matter, we tend to write them like this, where a, b, and c are numbers. For easy trinomials, we know that a is always 1. So really, easy trinomials look like this. When you go to factor them, if you're struggling with the signs, start by looking at c. If c is positive, the next thing you're going to do is look at b. If b is also positive, then the signs inside of your two factors will both be positive. If c is positive and b is negative, both of your factors will have minus signs. Now things get a little messier. If c is negative, now you've got a case where your factors are going to have two different signs. So you've got to decide if b is positive, then the big number will be positive. And similarly, if b is negative, the big number will be negative. This we used as we did all of these examples, but there it is in a chart for those of you who need it in a way that you can actually see it all laid out. Okay, head back to your notes. There are more examples there to look at and more explanation. And as always, there are some textbook questions.